Okay, on this video I'm going to show how to solve an example of variable separable differential equation. Okay, now the first step, it is actually to separate the variables, which is the same as we did in the previous video. Okay, so I'm going to repeat the process, and it's going to be 1 plus x derivative y respect to x equal to y, and then I usually solve the problems left to right and then down. Okay, so this is going to be, let's separate the variables differential of x as a multiplication, the y as a division, and this as a division. So it's going to be differential of y over y equal to differential of x over 1 plus x, right? Okay, now here, this is the same as the previous, but here comes the next step on solving. We are going to apply the integrals in both sides. So we have to apply the integrals, we have to solve this integral respect to y, and here we are going to solve this integral respect to x. Now, here an important thing. You can separate the variables, but you can leave it like that, like this. Y over the differential of y equal to 1 plus x over differential of x. Now you can see that the variables are separated. It doesn't matter if the y is on the right and the x is on the left. But we have a problem here. Even though they are separated, the variables, you cannot solve it. Because if you apply the integrals, these integrals cannot be solved. Cannot be solved. Why they cannot be solved, those integrals? The reason is that there is no formulas of the integral tables or formulas where the differential is in the denominator. The differentials always are in the numerator. Okay, so even though it is variable separable differential equation, from here this is wrong. Okay, now this is the correct path. So I'm going to make a note here and make sure the differentials, meaning differential of y and differential of x, are in the numerator. Otherwise you cannot solve it. Okay, so now here let's continue with the process. The first step is to separate the variables. The next step is to apply the integrals and then solve them. Okay, so let's solve them. So the integral of 1 over y, differential of y, is just simple, the natural logarithm of y, equal to the integral of this. It is also the natural logarithm of 1 plus x. Alright? Okay, just a little comment here. Equal to the natural logarithm of 1 plus x. Okay, now, every time you take an integral, you have to add a constant. Because on the left you have an integral, then you have to add a constant. On the right you also have an integral, then you have to add another constant. Now this is the constant of the y integral, and this is the constant of the x integral, right? Okay, now you have two constants, but in reality you have only one constant. So the natural logarithm of y equal to the natural logarithm of 1 plus x. If you pass this to the other side, it's going to be plus the constant of the integral of x minus the constant of the integral of y. Now, there is no need to write two constants, because this constant minus another constant is just a single constant. So there is no need to write two constants. One constant is enough. So let me make that note. No need to write two constants. And when I say two constants, the constant of the integral of y and the constant of the integral of x. So only one constant is enough. Okay, so the solution of the integrals will be the natural logarithm of y equal to the natural logarithm of 1 plus x plus a single constant. Alright? Now, here, engineers, is already the solution. But this solution is implicit solution. And it is a family of solutions because you have the constant. Now, Okay, now, is it possible to clear the y? And to clear the y is to get to the explicit solution. And the answer is yes, we can clear the y. It's not difficult, so we are going to seek for the explicit solution. And here what we are going to do is to apply the exponentials on both sides of the equation. So it's going to be the natural logarithm, exponential of the natural logarithm of y equal to the exponential of the natural logarithm of 1 plus x, and then plus the constant on both sides. Now on the right side, what I'm going to do is the following. Exponential of the natural logarithm of 1 plus x times the exponential of the constant. I'm using the property of the exponentials, or of the power. If you have an addition here, means that you have a multiplication here. Alright? Okay, the exponential of a constant is also a constant, so there is no need to write exponential of the c of the constant. This is just another constant. Right now, here, the exponential of the natural and the natural logarithms, they cancel. That is why we apply the exponential, because they are opposite operations. So they cancel, and here you have the y equal to the constant, and here this exponential and this natural logarithm cancels, so it's going to be 1 plus x. Now here is the explicit solution. Explicit solution, and this is the solution we are going to look for. Alright, now, because this problem doesn't give you an initial condition, then that's it, you finish. But what if they provide you with the initial condition? Okay, let's say that you are given an initial condition. And remember, the concept of the initial condition is that this is the family of solutions, so that means that you have a lot of solutions, family of solutions. I'm just drawing a pattern of solutions. It doesn't mean they are like this. And the solutions will be, if you are given an initial condition, means that if you are given a point, x0, y0, then they are asking you to get this solution out of the family of solutions. Okay, let's assume an initial condition. Let's assume that you are given y of 0 here, y of 1 equal to 6, for example, just as an example. The method to calculate the constant is just replace the values of x and y. Here, the value of x is equal to 1, y and the value of y is equal to 6. All you have to do is to replace in the solution and calculate the constant. So let's do it. So from here is going to be y is equal to 6 equal to the constant 1 plus 1. And how much is the value of c? C is equal to, this is 2, and 6 divided by 2 is equal to 3. Okay, so you have calculated the constant c. And then the specific solution, y is equal to 3 times 1 plus x. And that is the explicit specific solution. Explicit specific solution. Alright? And this is the method to solve differential equations using the variable separable differential equations. So, just let me write the main steps. The main steps are, this is the first step, separate the variables, and once they are separated, then you solve the integrals. This is the second step, solve the integrals. Step number 3 will be once you solve the integrals, then if possible, number 3, clear the y. Okay, once you get the y, then step number 4, if you are given an initial condition, then calculate the constant, and that's it. Alright? So this is mainly the procedure with a simple example of how to solve it. Next video, let's solve another problem, but more complex. Alright? See you in the next one.